So, once more, good morning, everybody. We start our, let's say, seventh lecture from previous session. As I told you, we start to work on GIS in a real manner. And today we are going to work and start to work with data, different type of the data. At the beginning, I will give you a very quick lecture about the data, and after it we're going to start with the rest of issue. So as I told you, today we are going to talk about the database and query, especially in ArcGIS. Of course, I'll give you a comprehensive information about the database and how a query could be shaped and what's the database. So first of all, a database, we use it for gathering or collecting the information in a very organized manner. The advantage of the database is easily accessible, easily manageable, and easily updatable. So you are also work with a database. Definitely you have experience about it. For instance, I gave you from a site analysis. When you start to make a site analysis in, let's say, very let's say basic level or in a amateur way, you have definitely two paper. One is your map, the other is your note paper or notepad. So you start to index to each parcel of each building, for instance, 1, 2, 3, 5, 4, 6, until to the end. And then in another paper or in your notepad, start to mention, for instance, number 1, what's the specific information about number 1, 2, 3, up to end. So same thing, same concept will follow here, but in a very professional manner. So fundamentally, any database or any data set is organized or developed with row and column. Later, we call a row as a record and column as a field. All this record and field or rows and column create a table for us. And in order to save the information inside this, let's say, table, or in order to start recording the data, we need to give some index. The index is similar as the numbering that you put in site analysis, this 1, 2, 3, 4, 5, up to end. So it means that each entity or each object have a specific and unique number. Like you, any of you have an ID number, any of us actually, inside the university, inside your country, or in any specific organization. So imagine inside the university, each of you have a unique student number. You cannot find two students with a common number. It's impossible. If you find, it is a bias, so it is impossible. So like in your country, each of you have a very unique ID number, like in Turkey, in TRNC, all in your country, or in international manner, your passport number somehow work in a unique way. So, as I said, we are start to use this database. Database advantage is decrease our workload because we are easily able to update the data and then we are able to retrieve it. So that's why we use database. We have a bunch of different databases, but all of them, the concept, the working process is same. For instance, the simplest one is Notepad. If you remember in, I think 2 or 3 courses before, for a quantitative data set, I start to make something like this. I just say number, and I put the ampersand, and then I set a class, another one, and then frequency, and then I start to say something like this, and then say 1, 20 to 25, then I set, let's say 20, we have a frequency of 5. Same thing, 2, again, let's say 25 to 30, then we set. If you follow here, these are the fields, these, let's say, vertical one. And the horizontal one, except this caption, are the record. This is one record, this is the second record, and this is our index number. So the simplest data set is this Notepad file. You are able to make a very simple data set with use of this one. If any of you work with a total station, the output of total station is something look like this one. So this is about data set definition. So now I'm going to show you a data set with a bunch of tables. This is a big, let's say, database schematic. We have lots of tables. All of these tables connect to each other. So imagine, let's say in a big scale, imagine a country. So we need have one table for personal information, like ID card, name, surname, birthday, birthplace, father name, mother name, or blood group, and etc. This is one table, let's say, for your personal information. So you have an educational information also. For instance, what's your educational level? Did you finish your secondary school, pre-university, university, or let's say master, undergraduate, bachelor degree, and etc. So one table related to your education, which is connect to your information. So I'm talking about a very smart country, which is everything connect and work together. So you have also, let's say, another table belong to you, like your, let's say, document about your driver license. If you have a driver license, what is your driver license number? So driver license number is the index number of the driver license. Your class of the driver license, which class you can drive, D, C, or let's say motorcycle, or let's say truck, or minibus, bus, and etc. When you get the driver license, do you have any penalty or not? This is another table, so which is connect again to your personal information. So imagine these all can be worked together. For instance, if this is an educational one, which is belong to you, this is itself connect to the Ministry of Education. It is connect to your university. It is connect to your school. So all work together. So to create a database in a, let's say, in this scale, you need to have a very good group. So, as I told you, everywhere we have a database. Now, with this big example, let's come to our university. Imagine this is our university. So, I'm just going to one of these tables. Imagine this is a university table, as I told you, which is connected to your personal information and educational information. And now, this is a database for university. Imagine this is a data table for university or for our university. So, under a university, we have a student table, which have a many other table under it. For instance, this is personal information. This is about the course that you take. For instance, if you go to the health center, they start to write your information. This is about, let's say, your health information, about the instructor or advisor, or how many courses you take, what is your course grade. These all can be under your student table. If you have a debt or you don't have a debt, if you stay in a dormitory or if you reside in the outside of the campus, so everything is there. So let's go to the another one. We have a personnel. We have a different type of the personnel inside the university. We have instructor, we have administrator, we have security, etc. and etc. So these are all can be shaped under the person. Actually, maybe it's you want to ask what's the relation of this one to the GIS. I start to make an example which is too much understandable for you, then is going to the GIS. So under the university we have different department, faculty. In each faculty we have 10 different type of the table. For instance, number of the building, number of the floor, number of the room, or capacity of the room. Everything can be located there. So we have many other table can be shaped. For instance, if you want to make a database or data set for a university, it takes maybe like a month of study. You need to start and sit from, let's say, main entrance of the university and look into the job process, then start to shape a table and table. Then go to the next place, then go to another place, then try to find the connection between these tables in order to make a database which is work in a strong manner. Let's come into the information era right now. So any of you, by your shopping preference, so any of you also have a data set. So internet from your telephone or from your computer, they understand what is your interesting things. These are going to be recorded inside your table. For instance, if you are interested in a football, in a soccer, in a tennis, if you are interested in a music, in a fashion, accordingly, these tables are going to shape in under your personal information. So when you start to looking, when you start to moving, accordingly, the advertisement and information based on your table start to deliver to you. So this is how it is work in a real manner.
Yes, I can.
Okay. So as I tell you, when you start to going to the shopping, when you start to shopping, for instance, if you go to the, let's say, Onder or Lemar or any shopping, Unimar, so each of you also, when you start to buy something, all the data start to connect to you. For instance, you start to choose something from the shelf, a rice, milk, or potato. All of these things are recorded inside the database and connect with your credit card and accordingly they understand your budget and everything. These are all work together as a big data set. Now, let's continue with the database and table. We just coming to the student. As I told you, this is a student. Here, under it. Under the student, we have a student number, for instance, 113359. It is a study in architecture. The name is Abuch. The last name is Sharon. Age is 21. The gender is male. Nationality from Israel. And the CGP is 2.58. So same thing for other students. For instance, 145197, for instance, study in a geodesy department. His name is Bridget, last name is Kleinschmidt, 35, female gender from Germany, 3.75 CGPA or overall grade. So these data, as I told you, each of these column in a vertical manner are a field, and each of these horizontal one are record or raw. I want to take your attention to the type of the data. If you're looking, these are just number. These are just a name. Again, number, but maximum 2 or let's say 3 digits in a very rare manner. Again, alphabet. It is 2 type, F or M. It is nationality, which is country. CGPA, again number with a precision. So each of these data again connect to each other. For instance, maybe you know or you don't know, our architecture department is, the department ID is 71. Civil engineering is 22. Urban design department, if I'm not wrong, is 75. Interior architecture is 72, and etc. So it means that each department also have an ID. Now, the ID or index, if you remember, I told you about the field inside the GIS. I told you I will going to tell you what is the field or FID. So this FID is this index number, or we call it in a professional manner, primary key. So primary key, it is our index, let's say, column or field. Same thing here. This is about, again, in GIS we call it FID or field ID, but here it is a primary key or, let's say, main key. So this is our foreigner key or secondary key. We need almost a second key in order to reach to our data quickly and also connect this data to the second data set. For instance, we can say that architecture from this foreign key connect to the primary key. It means that many students like you, we are almost here 12, can be studied in architecture department. Okay, many students with a unique primary key can be studied in architecture, but you cannot find 2 students or 1 student study in 2 departments at once. It is impossible. You cannot find, for instance, one of you, let's say Abbott, cannot be studied same time with this student number in architecture and civil engineering. Of course, we are able to open a second student number and study in 2 different departments. So, as I told you, many students can be studied in one department. So this is our student table, this is the relation, and this is a department. So many students can be stuck in one department. Now, what about the query? What is query? The query is like a question. You start to question the data. If you remember, actually you use it in a Google. Up to now, you always use it in a Google. You write a query in a Google or in your URL box, and this start to make a query on the background, which you cannot see it, and start to ask a question from a relevant database, and then provide you an answer. For instance, if you remember in GIS, at the beginning course, I tell you, you want to open a market. You need to write a query. You need to understand what is a suitable place for opening, let's say, a grocery shop. You need to find a place which have a cheap land, which have accessible, also have a density of the people and less amount of grocery shop in, let's say, 1 square kilometer or 500 square meter. Then your, let's say, investment will be win-win. Now, let's start to write a query here. The first thing, we need to say select. Select means that the choice. You can say update, you can say delete, but here we call it select. We want to find all students with a CGPA over 3. How we are going to do? We are going to say select from a first name and from a last name. First name, last name, first name, last name. From, it is a table name. This one is attribute. We select the attribute, first name and last name are attribute. And from, this is a student table. As I told you, we have a different table, but now we are going to select from the student table, where it is our condition. Of course, it is optional. If you didn't say any condition, every student will appear. But our condition right now is CGPA over 3. So, in this way, we need to write where CGPA is bigger or bigger and equal to 3. In this way, a student with CGPA more than 3, like this one and this one, will appear. Now, sometimes you want to write another, let's say, condition. You want to write, show a student who study in civil engineering. When we dealing with the alphabet or character, we need to put the alphabet and character inside the quotation. So in some GIS, single quotation, in some GIS, double quotation. In ArcMap, we use a single quotation. Because it is a character, we need to say to the computer, character start exactly from capital C and finish on small l. So again, when we write, this is a condition. We can have a double condition. We can say show from a civil with a CGPA is equal or bigger than 2. So it is just check all the students have a CGPA bigger than or equal than 2 and also study in civil engineering. So this is about the how we write a query. Now, as I told you, if you're looking here, we have a different set of data. This is very important. We need to know which type of data we are going to use. For instance, this is a character, this is a number, this is again character, this is number, and etc. So if we have a, let's say, short integer, the range of the short integer or the length is about 32,768 minus and plus. Why this is important? Why not choose this one? So, as I told you, you need first to analyze your data. What type of data you are going to store? Is this a 6-digit? Is this 7-digit, 8-digit? Is this telephone number? Is this a 2-digit number or the number with precision? Because if you want to make an efficient data set, you know that the space in an internet or space in a computer is valuable. If you make a huge data set which is not efficient, so your speed starts to decrease. So you need to keep in your mind which data or which type with which range is useful for you. For instance, if you want to save the years, like 1966, 1969, 2021, 2000, so maybe this one is good choice for you. But if you want to save a big number, you need to use a long integer. Of course, this, let's say, long integer are capture a big space in comparison to the short integer. Again, we have a single precision or float. The float, the number is 3.4 to the power of 38. The minus range and the plus range is 1.2 to the power of engineering 38. So this is also capture 4 bits. So if you have a precision, you can use this one. But if you have a double precision or very accurate number, you need to use this one. For instance, text. Of course, the text is varied. The amounts are very up to the 64,000 character. You can put a text there. For instance, if maybe some of you have experience in Twitter, you cannot write more than a specific amount of the character. It means that they are limited you. For instance, if you are working with a name like this sort of name, you will see that 1, 2, 3, 4, 5, and 6 characters. So if your name is like 10 or 11 or 15 characters, then you can say that I want to assign maximum 20 characters for my name. But if your name is long, so accordingly, you need to assign a big amount of the character to your text. We have also data. The date, sorry, not data, date. The date include month, day, year, hour, minute, second, and AM and PM sign, which also take 8 bytes. This is also used for a date. Now, keep it up to here. Now come to the GIS. We are going to start to work with same thing. I'm just enter to my computer. Any question up to now? Anything that you want to ask? So I'm going to take example number 3, and we are going to work with example number 3 for this question. Let's wait a few seconds until the staff website is loaded. Yes. This is example 3, and we are going to work with example 3 for this course. And also we are going to work with example number 2 at the end of the course. But right now we are going to work with how many GIS I need into. Go to my downloads. This is example 3. Put it there. Let's extract it. I get rid of this one. And we have example 3 in our desktop. We need to make a folder connection from add data because I don't have it right moment. I just used a folder connection, connect to the local PC from desktop. Example number 3 is under my folder connection right now. I choose, let's say, parcel and all together. I'm just going to open my data set for a parcel. When I'm just open attribute table, this is FID. The FID or field ID is similar to this primary key. Actually, it is a primary key. So it means that any parcel have a unique number. If I choose a parcel number 50, which is a very bad condition, it is located here. And if I choose this one, which is a good, locate here. Now, we want to investigate or buy a parcel which have a good structure. How we are going to find? We need to just going to selection, select by attribute, like the query that we are going to write here, select by attribute. We choose select by attribute. Is it saying yes? Select everything, the attribute. Here we just, in a GIS, it makes your job very easy. Select everything. If you also put a star here, you can say everything bigger than 3. In that case, you can, when you select everything show, not only first name and last name. The department, age, gender, nationality also appear if you put a star, which means that everything. Now, we are going to select everything which is okay for us from wall. Wall is not a correct. This layer is our table name, exactly like here. From which table you are going to select the student. Here, because we are going to work with a parcel, we choose parcel. So this one work as a parcel. Now where? Where is our condition? What is our condition? Our condition is a structure field should be equal. Let's get a value. Very good. Okay. So if I just hit OK, all the structure with condition of very good will be choose 28/987 parcel choose, I can filter it, and these are all very good parser. Same thing, as you can see here, they put it in a single quotation. If I'm not put it a quotation like this one, if I apply, nothing show, because computer cannot understand what does it means. So then you need to put it in the single quotation. Another important thing, computer and data set are case sensitive. It means that if I write V with a small j, of course my query is correct, but there is no value with capital V and a small g, because computer is case sensitive. I put VG or VB, it shows everything. So this is first step. Now, you want to also, let's take out of the filter, you want to also calculate the area of each parcel. What is the area of each parcel? For instance, what is the area of this parcel? You want to calculate. If you remember, you can do it from here, but this is very amateur way if you want to do it from here. And of course, you have a amount or marginal error definitely. You need to open a field from here. You need to add a field. Just you are going to here and click on add a field. So it asks you a name, just give you a name. You can say area or square meter. So for an area with a square meter, what type of data we need? So area is not a, let's say, a discrete number, because these two, short integer and long integer, are discrete. Area is always a continuous number. You cannot say definitely this land is, let's say, 120 square meter. Definitely there is amount of precision. And since we are working with land is valuable, so we need to consider all these precision. So this is very important for us. Accordingly, we need to calculate all precision here. So therefore, we choose the sensitive one, which is a double. Let's go here. You see short integer, long integer, float, double text, and date. Same thing here, short integer, long integer, float, double text, and date. Some data sets, some of the database also accept a Boolean. Boolean means 0, 1, or yes or no, open, close. Just two conditions. So, as I told you, square meter, I choose double. We don't need to change the precision and the scale, because we are not sure about the precision and the scale amount. As I told you, it is land. Hit OK. Area square meter. Predefined is 0. We need to just select. We want to calculate the area. We just right click. We say calculate a geometry. As you can see in a description here, it's called about the area, perimeter, length, and etc. Hit OK. Ask you, do you want to do it? Yes. So, what is a property? What you are going to do? You want to make area calculation, perimeter, or 3D perimeter, etc. and etc. We choose area. Don't touch this one until our coordinate course. I will going to tell you what is a coordinate and why it is important for us. At the moment, just keep it as it is. We have different bunch of unit for area. Hectare, a square decimeter, square feet, square kilometer, or square, let's say, meter. I choose a square meter as we define it also here. I hit OK. Yes, you want to calculate, do you want to continue? Yes. All the parcel, the area of all parcel calculate. Now, since I have the area of all parcel, now I want to have a double condition. Let's say we want to find a parcel, we want to buy, let's say, a parcel which have a very good condition. And look at here, we have now one more field here. So, say, select from parcel where our condition structure equal to the, you know that it is a VG or very good. What is our second condition? It is AND. We need to make AND. You can add from here and, or you can write it. This time, area square meter, we want to say it is, let's say, bigger than and equal to, let's say, 120 a square meter. First, we verify. The verify means that your syntax or your query is correct. Verify, fine. And now I say apply. 23 parcels select. If I am filter, all these parcels have very good and also bigger than 120 a square meter. If I am just get rid of this one, now 23. This one, it say 28. So it is filter my parcel. Now, let's change this one. I want to say that parcel from 300 bigger than equal 300. Let's make a 3 condition. And again, area, this time less than equal 400. I'm just check, it is verify my condition, apply. So just 7 parcel with this condition found. Then now you are able to decide which one you want to buy or which one you want to investigate. These 7 have a very good structure condition and the area square meter of them are between 300 and 400. You can change the condition to, let's say, bad. Again, 22 parcel have a bad structure and the area between 300 and 400. This is about the writing condition. Up to now we learn how we are able, up to now actually we learn what is database, the relation between the database and the field record, primary foreign key, and also how we can write a query inside and call the data and what is the data type. Now, I'm going to make another field. Let's deselect everything. I'll just deselect everything and let's show everything also. We want to say that, let's say, We want to put also a price. Let's say price SDG or sterling. I'm start to think what kind of data I need. I want to say that if the parcel is very good, the very good parcel is per square meter is a 400 sterling. Let's delete price and say here square meter per sterling. I want to say a maximum price is a 400 sterling and minimum price is 100. It means that this short integer enough for me. So I don't need to choose this one since my range is between 32,767 minus and plus. So therefore I choose a short integer. I just hit OK. I want to say, please find all the very good parcel. 28. You see, these are 28 parcel, which is select. These 28. I want to say that field calculate, I want to add a data. I want to say that S square SDG equal to 400. So if I hit OK, all this data, all the ones with very good, become equal to the 400. Now same thing. I want to say that the ones is good equal to the again the relevant parcel with good become 300. The ones that bad, let's say it is 200. The ones that it's very bad or VB are 100. If you remember, we have also open space or OS. I want to say all open space parcel, because there is no structure on it, it's cheap, let's say 50 sterling. So now I create all the different data. Now just deselect everything. We want to calculate the price of the parcel. We just add a field, let's call it price. Now, I just want to take your attention. For a price, we have an area and we have a square meter sterling. We want to multiply this one to this number. As you see, this one have a precision and this one is the short integer. When we want to multiply two numbers together, dependent to our accuracy, we need to choose the data type accordingly. If you want to calculate accurate price, since this one is a double, our result definitely become double 2. So I need to choose a double as well. I'm going to show you what's the difference. Let's call this one double, hit OK. Now let's calculate the price. We just again go to the field calculate, this one for calculation, this one for a geometry calculate. We come here, hit OK. We want to say that price double equal to the area multiplied by sterling amount. When I just hit OK, this is a accurate price, and as you can see, some of the number is big, like a 96,429. So imagine now I want to make a field, call it again price with short integer or SI. I am create here. Let's start to make a field calculate. We say price SCI equal to the area multiplied by a square, same, let's say syntax. If I hit OK, we say it gave us an error because some of our record, like this one, is out of the range of a study. If I say OK, continue, you see, the big data, like this one, out of this range, are not calculated. If you see. And also, you see, there is no precision in my data. Let's also do it one more with, let's say, price, this time with long integer. Make it big. Again, field calculate. Let's write once more. Price long integer, we want to say square meter multiplied by price. Sorry, price multiplied by square meter. It doesn't matter because it's multiplied. If I hit OK, this time all number calculate, but without precision. Since we are dealing with a number, with the money, the precision is very important. So that's why we prefer this sort of data. Accordingly, you need to choose a data according to your data set, and you need to also take care of the data set capacity. Now, let's come here. I want to get rid of this wrong one. Let's just choose a delete field and a delete field. And let's write one more some query. We want to say that find all parcel with a square meter bigger than 300 and a square meter between 300 and 350, and price of a square meter, let's say bigger equal to 300. If I am hit OK, all the parcel with this specific area between 300 and 350 with price of equal to more than 300 sterling is appear. We have 25 parcels. So this is how you can shape a data and how you can able to manage your data. This is up to now. Now we are going to work in another things. The population density, most of you, especially in architecture and planning, in urban design, you need to calculate the population density. The population density gives you lots of information. A very simple formula is the number of the people per land area. It can be square meters, it can be square kilometer. So according to the population density, you are able to learn many things about the study area. This is, for instance, Turkey. As you can see, this region is Istanbul, have a very dense population between, let's say, 501 2000 500 to 2500 people per square kilometer. Accordingly, this one is a less dense area, this let's say a yellow color, or this one are medium density, for instance, Antalya, Muğla, and about same thing about the Europe continent. So this is about density. Now I'm going to show you how we are able to start with density. And before going to there, from the table that we create, we are able to learn different statistics like a standard deviation and etc. Let's look at here. If we just open the attribute, let's deselect everything and appear everything. If we choose one of these fields, you are able to find a different statistic about it. For instance, what is the count is 987 record. What is the big number? What is the smallest number? What is the big number? What is the mean of the whole number? And what is the standard deviation? Do we have any null? No, we don't have any null number. Same thing for other. See, all the frequency distribution, everything is going to give you accordingly. And you can also get a summary from your table. For instance, you choose which part you want to get and which data. They gave you according to the price maximum. You can say that minimum price from the square, let's say sterling, the average price take from structure. Of course, this one become meaningless because the first one or last one is not. Then you start to create a report for you, and the result will be shown in an output table for you accordingly. This is the result. So this is the report that you are able to take. Let's put this one here. So different things that you are able to get. Also, you are able to find the property. Is this double? Is this a precision? This one definitely is a text. You see a string. A string and text are same. The length is 3 because we have maximum 1 character or 2 character. Even 2 length is enough for us. Now, let's go to calculate the population density and get rid of this example 3. I'm going to download example number 2. Let's take this one to the desktop. And we are going to calculate a population density. And just drag and drop over it. Here we go. Get rid of this one. Oh, I'll just close also Archman. Let's close this one. We don't need it anymore. So to connect, we choose add folder. We make a connection to the folder, to example 2, and choose this one, province. It's appear. This is example 2, which is familiar for all of you. As I told you, I'm going to calculate a population density like this map. We are going to open an attribute table. We are going to open a field. So before start, we need to think that what kind of field we need. Based on this formula, we need number of people and land area in order to calculate a population density. We have a number of people here, but we don't have land area and population density. We need to open a land area. Let's say land area. Since we are working with the area, as we say, the double is important because area is an accurate number. We just say double. What else we need? We need also a population density. So, like a previous example, double number multiple into the double number. Definitely result is double. So again we choose double 2 and we call this one, let's say, call it pop or population density. If your name is longer than a specific character, the computer going to minimize the length of the name. And hit OK, like here. You see, population density is too much long. Computer minimize it to the pop density. We can also make it like this one. Because I am used, be careful, don't use a point in the field. Let's take it like this. It's population density. Now, we need to we need to deduct number of the people to land area. First, we need to calculate the land area. What is the land area unit? As you can see here, as you can follow here, it's kilometer, square kilometer. You see, per square kilometer or per square mile, not meter, because the area is very big. We are talking about a country, so square meter cannot be worked. We just go to the calculate geometry, hit yes, of course area, but this time square kilometer. Hit OK, yes, the area calculate. Now we need to calculate a population density. For this purpose, like our formula, number of people divided to the land area. We have two population density for two different periods of the time. It doesn't matter, one of them. We just choose the first one. Number of people divided to the land area. If we hit OK, yes, you see the population density is appear, which is same number range of the year. You see 11, 40, 41, which is same range. You see the maximum population density is here. Of course, you are able to classify it from the classification. Since it is quantified, quantitative population, you can make it like this. You would say use a natural chain break. You see here is a maximum population density with between 106 people to 387. Of course, you can make the range small. You can say, let's call it 16, and let's call this one 4. Again, you can say 16, 5, again 35, 207, and 107 to 388 in order to cover the whole number. We apply, okay. You see, same thing is appear here. So this is about the query and data set. Any other question related to our course, related to anything else? It seems everything fine. I'm going to stop our course and wish you all the best in your midterm. I put a video like every time into the YouTube channel. Try to subscribe our channel in order to get a notification and get our video. Hope you all the best. Have a good weekend and be successful in all your exam. If you have any question, you can write me in a WhatsApp, Instagram, or email. See you. Have a good weekend.